Hello, my name is Javed Ahmed. I'm here to present my second capstone project, New York taxi trip time prediction. First, we know about our project. Our project is New York taxi time prediction using different algorithm, machine learning algorithm. Our main aim to predict the time of duration of taxi trip, how much time it will take for a proper ride. In this project, we create different types of machine learning algorithm and evaluate using different metrics such as mean square error, root mean square error, R2 score, and adjusted R2 score. Comparing different matrices, we found a best and optimal machine learning algorithm. So let's begin our project. Our problem statement is that we have to build a machine learning model to predict duration of New York taxi time trip using different type of features like pickup time, drop up time, geo coordinates, and number of passengers, and several other variables. So first we have to import necessary libraries like pandas, numpy, matplotlib, seaborn, scikit-learn, and different parameters like decision tree regression, linear regression, random forest, XGBoost, gradient boost, and many others. So first we import our dataset and explore our dataset. We know that in our dataset we have almost 14,15,644 rows and 11 columns. In 11 columns, 10 are independent feature and 1 are independent feature. And the dependent feature is our target value. So by DFW info, we know that we have no null values, and we know that all the data types are in correct format. Only two data types like date time and date pickup date time in object form, so we have to change it into the proper format. If we talk about duplicate values, there is no duplicate values. Yeah, we can see that there is no duplicate values and no null values, and all the data types are in proper format except these two, pickup date time and drop out date time. So if you talk about columns value, we have 11 columns: ID, unique ID, vendor ID, unique identifier of vendor, pickup date time, drop date time, passenger count, the number of passenger in the vehicle, pickup longitude, pickup latitude, drop off longitude, like geo coordinates, and store and forward flag. It means whether the trip record was held in vehicle memory before sending the vendor or not. So if you talk about our some statistical numerical features only describe, we know that vendor ID has minimum value of 1 and maximum 2. It makes there are only 2 vendors, and some passenger count has also 0 values. It means either driver entered wrong values or driver complete the trip without any passenger to complete our target. So we go to our next topic, EDA, that is data wrangling. So we know that our date time format in object format. So we have to change into proper date format. So by this command we change into the date time format and extract extract the different types of value like month, day, weekdays, hour, and the name of day. So by by extracting this value, our features, number of features also increase. Our target value, that is trip duration, is in a second, so we have to change into the minute. By the geo coordinates, we found the distance between two latitude, longitude, and a drop of latitude, longitude. For this, we use a geospy distance Great Circle library. So let's go to the visualization part. Our first visualization is that most of the trip taken by the vendor ID2, almost both are almost same, but vendor ID2 covers most of the trip. It's clearly seen by this pie chart. If you talk next, if you go with our visualization 2, then we can see that less than 1% trips were stored before forwarding to the vendor. If you talk about next visualization, we can see that most of the trip are taken at Saturday, Friday, that is weekend day, and same situation in dropout day, because we know that Saturday and Sunday is weekend, so many people booking taxi for their parties and celebration and other things. So maximum trip ride were taken at Saturday and Friday. And if you talk about time zone, which time that trip is taken mostly, then we can clearly see that the evening time most of the ride are taken, and least ride is taken in the morning before 10 o'clock. The reason behind that most of the ride taken at the evening is that people come from office at the evening, they take ride, and after that most ride taken at the midday. Midday means after 10 o'clock. After 10 o'clock, people go to the office and many other things. At the late nights, ratio is a little bit less compared to the morning. Okay. Next, if you talk about trip duration, we clearly see that after the March month, the trip duration is increasing month by month till June. After June, we have no data, so we can see that after February of March, the trip duration rising rapidly. If we talk about at hourly basis in 24 hours, we can see that at 6 o'clock, at 7 o'clock, maximum ride will be taken by the customers. The reason behind is that this is evening time, people go for the dinner and the many other things. Okay, if you go to the next part, we can see that that pattern behind both the vendors to take a trip in the month is almost same pattern. The trip is maximum for the vendor 2 is March, for vendor 1 is also March, but the most trip will be taken by the vendor 2 compared to the vendor 1. There are maybe different reasons why the vendor 2 has taken more trip. Maybe the cost of the ride is little bit low compared to the other, and maybe the service is good of the vendor ID2. Okay. If we talk about the customer count, we see that there are 60 customers, there's 60 right, which has 0 customer. Means if maybe driver entered wrong values, or maybe driver rides alone to complete their target. By this distribution, we can see that most of the ride will be taken by the single passenger. We notice that most of the booking are made by the solo travelers, which means people are avoided to prefer carpool, or maybe less number of group book cars. People prefer to ride solo. If you talk about the chart 8, we divide in our trip duration into the different bins, like less than 1 minute, within 10 minutes, 30 minutes, 1 hour, within day, 2 days, more than 2 days. If we plot these data in our bar plot, we can see that most of the ride duration between 30 minutes to 10 minutes, and within 2 days, more than 2 days are very rare, and less than 1 minute is also very less. So most of the trip duration between 10 to 30 minutes. If we talk about the distribution of our different features, for this we plot a box plot and the histogram. By this box plot, we can see that passenger count. There are many outliers in the passenger count. After 4 passengers, we can treat as an outlier. The same situation is between distance. Distance also contains lot of outliers. A trip duration also many outliers, and the pickup hour and the drop hour is both mean and median are coincide. By this we can see that they are normally distributed, but these three are skewed and contains many outliers. So we have to consider that. By histogram and box plot, we can see that the trip duration are highly skewed, and trip duration we have lot of outliers. So by this outlier we have to deal it. So for this we have to check multicollinearity. By this, for that we plot heat map. By heat map we can see that, we clearly see that pickup month and drop month are 100% correlated, and if you talk about weekdays, drop of weekdays and the pickup weekdays, they are also 99% correlated. And our target value, that is trip duration in second and trip duration in minute, it also correlated 100%. So for better result we have to drop the correlated features for better performance. For this we define a function by the name of correlated. By calling this function, we found that we have 5 features, they are highly correlated. So for better performance we have to remove. We can see that the column are highly correlated above 90%. So for better performance we have to drop this highlighted value. If you check about the skewness of target values, by this distribution plot, we can see that our target value is highly right skewed. If you apply log transformation and then plot a histogram, then we can say that it absolutely normal distribution. So by this we can say that our trip duration is highly skewed. Okay. So next part, the main target is to remove the outliers. For this we use quartile method. Uh, by visualize we can see that trip duration, passenger count and distance, we have lot of outliers. So by this we use a quartile method. For quartile method we found the 25 percentile, 75 first quartile, third quartile. By quartile we found an interquartile range, that is Q3 minus Q1. From that we define our upper limit and lower limit. At the above our upper limit, that are outlier, and below from our lower limit, that is outlier. So we have to remove that data. So if I talk about the trip duration, less than 0 is treated as outliers. There is no meaning of less than 0 trip duration. So we have to remove that column, and the data which is upper that limit, we have to also that remove the data. Same situation in our passenger count. We remove the data above above the upper limit and the less than 0%. The same situation in our distance column. We remove the outliers by same criteria. After that we plot the distribution plot and trip duration. We can see that they are absolutely normal distribution. So we have a lot of textual data column. So for the better performance we have to convert into the numerical column. For which we have to do on hot coding. So by this pandas get dummies, we change into the numerical data. Instead of dropping irrelevant collinear columns, we make a separate features column. So we make a different features column and our target columns. So next part is our main part, that is to create a machine learning algorithm. Our 50% work is done in EDA, removing outliers, data wrangling, and other things. Our next our important part is that is create a build a machine learning algorithm. So for this we define a evaluation matrix which calculate mean square error, root mean square error, R2 score and adjusted R2 score, and plotted the actual prediction, predictor value and the actual value. So and split our data into the train test data and train data into the 80:20 ratio. Okay. Our first model is the linear regression model. By fitting the linear regression model, we see that our R2 score is 48% and adjusted R2 score is 48%, which is very poor. So we can see that this model is not best fit for this situation. So and if you talk about our evaluation matrix of test data, the same situation, 48% and 48%, and the mean square error is 22 and 4.73. that is bad model for this data. So we have to check for another algorithm. Yeah, we can see that R2 score is very less and MSE is pretty high, so this algorithm is not suitable for this model. So our next model is the decision tree. If you plot decision tree to without any giving any parameter, so is plot until uh, all until full depth. So then if you give you this a full depth, they it totally overfitting condition. So to avoid this overfitting condition, we give a proper hyperparameter. So by giving proper hyperparameter, uh, grid search CV, we found better parameter. By maximum depth 12, mean sample leaf 20, split 10, uh, and best score 56. So by fitting this decision tree, we found that our R2 score is performance become better than previous one, that is 57%, and the R2 score is also increases 48 to 57%. So we can see that our that graph we visualize that most of the data are coincide with actual data, but there are some maybe some error. So we check another most important machine learning algorithm, that is random forest. So by fitting proper hyperparameter, by giving better best estimator, by giving maximum best feature, by giving mesh depth, uh, by fitted this random forest with this our data, we found that that it R2 score become 67%. It is better than previous one. Our previous one R2 score is 57%, and then by this random forest we found 67%. That is more better than previous one. So it also says that said by this chart, actual and predicted time duration. The same result will come from by the test data is slightly slow than the test data, but it's right good. So our next algorithm is XGBoost. By XGBoost, we found almost similar to the random forest. So we can say that the random forest and the XGBoost algorithm gives the slightly similar pattern, similar result. It gives also 66% on train data and 62% R2 score on test data. So if you talk about the importance of features, uh, we can see that the distance and the pickup weekdays are the most important features to calculating or defining our target value, that is the trip duration. So most important features are the distance, which affect our dependent variable is the most. Our last machine learning algorithm are the gradient boost. By importing all the parameters, by giving all the uh, uh, proper hyperparameter, we found that the R2 score is decreased by previous one, that is 55% on test data, train data, and 55% on test data. It is low compared to the other. So if you compare all the matrices evolution by different models, we can see that the R2 score of a random forest is better among 5 algorithm. After that, XGBoost, and the least R2 score we found from the linear regression. So then we can see the random forest and the XGBoost is the best algorithm for this data. If you talk about the MSE score and the RMSE score, we can see that the error is less in random forest after and a little bit high in XGBoost, and RMSE score also is less in random forest model. So by this whole situation, we can say that the random forest has least error, and the R2 score is also high for the random forest. So random forest is considered as a good algorithm for our training model. We have to deploy the random forest model for this data. So if you talk about the conclusion of EDA, we can see that from by the visualization that vendor 2 has more trip bookings, distribution and pickup and drops on daily basis interprets that we can see compared on other days taxi booking. The Friday and the Saturday bookings are high. Distribution on pickup drops monthly basis, so that in the month of March and April the bookings slightly increase. The maximum bookings in the month of March and lowest in the month of Jan. If you talk about the pickup and drop up time, its busiest time is at 6 o'clock at the evening, and after morning 10 a.m. If you talk about the passenger count, the distribution is most of the bookings made by the solo travelers, which means less number of people prefer pool car, or maybe number of groups book car. People like to travel solo. If if we talk about conclusion from our model, by our model we can see that the R2 score of our random forest and the XGBoost is higher compared to our three model, that is a linear regression, decision tree, and the gradient boosting. And the MSE score is also low in random forest. So by this whole situation, we can see that the random forest is the best and better machine learning model. So we try to taking an optimal parameter so that our model does not overfit. So that's all about our project. Thank you.